Good day, everyone. We are Group 1 and we are speaking on eclipse, lunar and solar.
So, I'm talking on definition of eclipse. Here, eclipse is the phenomenon of three bodies, which are the sun, the earth, and the moon. And this happens when they are all in a straight line. And the moon revolves around the sun once every month, which is called revolution. And the earth and the moon travel together, making a complete movement around the sun. When this occurs, the light from the sun is obscured from reaching either the earth or the moon.
So I'm here to explain the two types of eclipse. We have the eclipse of the moon and also the eclipse of the eclipse of the moon and eclipse of the sun. That's the solar and the lunar eclipse. So the solar eclipse is basically when the moon comes in between the moon comes in between the earth and the sun, which the moon gets it like the light it shines in the night, it gets it from the sun. So when it absorbs that, it casts a shadow on the earth. That's making one part of it divides the earth like this, making this part of the earth is going to be bright and this is going to be dark. That's what they call that's the solar eclipse. While for the lunar eclipse is when the earth comes in between the sun and the moon. That's making the moon, the moon is our only source of light in the night. So that throughout the night, that day, they're going to be total darkness. So causing that's the lunar eclipse.
I'm going to be talking on types of eclipse. We have total eclipse. This is when there is full darkness of the moon, as you can see right here. And then we have partial eclipse. This is when half of the moon is dark and one side is bright. That's when in night in the sky we see half moon. Example right here. And then annual eclipse. This is an eclipse of the sun in which a portion of its surface is visible as a ring surrounding the dark moon. As you can see here, this is sun and then this is the moon. So this is an example of annual eclipse. Thank you.
Yes. And there are some fun facts. In our world today, there has been some occurrence of eclipse, like in 2007, 2008, 2009, 2010. We've had the partial, the total, and the annular. Most of them, the highest recorded is 11 minutes and 8 seconds. That's all for eclipse. Thank you.
Good day, everyone. Today's topic is mirrors, and my group members are Sophia, Korede, Bukola, and Folum. Mirrors. This is a piece of special flat glass, so you see yourself when you look in it. We have three types of mirrors, two types of mirrors, plane mirrors and curved mirrors. Under curved mirrors, we have concave and convex. Key facts about plane mirrors. The images formed in a plane mirror is erect and not magnified. It can be big as you are. It is just the same size as you are. Virtual can be projected onto a screen. You can clearly see yourself in the mirror. Forms as far behind the mirror as the object in front of it, and it is laterally inverted.
So now, I'll be talking on characteristics of real images, virtual images, and parts of a mirror. So now, for real images, it is always inverted. It is formed on a photographic screen. Formation is by intersection of real or true rays, and not also rays of light actually pass through. For virtual images, it is always erect or upright. It cannot be formed on a photographic screen, and formation is by intersection of apparent rays. Also, rays of light do not pass, but they appear visible to the eyes. Parts of a mirror.
Parts of a mirror. There are actually 5 parts of a mirror. The first part is the optical center, which is also known as C. This is the point between the lens surfaces on its principal axis. Is the midpoint between the lens surfaces.
Then the principal axis, this is the line passing symmetrically through the optical center of the lens. Then the principal focus, F, this is the point where all rays parallel and close to each other, close to the principal axis, converge and refract. That is also known as the focal point. Then the focal length is the distance between the principal focus and the optical center, C. Then focal plane, this is the plane that passes through F. It is perpendicular to the principal axis. As you can see, this is the principal axis here, the plane that passes through the optical center. Then this is the focal point, F, where all the rays converge, where all of them meet. Then this is the optical center or center of curvature, the middle. Then this is the focal plane, it passes through the points. Then the principal focus is the focal length. Yes, so now we have the lenses. The lenses are simply the combination of two mirrors, either the concave, the convex, or the plane. The first one we have is the convex mirror, convex lens. This is the mixture of two convex mirrors to form a lens. Then we have the concave lens, which is a mixture of two concave mirrors to form a lens. Then we have the plano-concave lens. This is the mixture of a plane mirror, which is just a simple flat mirror, square-shaped, and a concave mirror to form a lens. Then we have the concavo-convex lens, which is the mixture of a concave and a convex. A convex and a convex. Then we have the plano-convex lens, which is the mixture of a plane and a convex mirror. Yes.
Okay, so I'm going to be talking on total internal reflection in the natural atmosphere. So I'm sure all of us have watched those movies where you are in a hot desert and you start seeing two of one object or an object that is not really there. This can be explained by the phenomenon of mirages. A mirage is a natural effect due to total internal reflection occurring at the boundary of hot and cool air. Okay, so if you go to a beach, you realize that closer to the ground, the air is hotter than higher up in the atmosphere. So that cooler air is actually more dense than the hot air next to the bottom. So as rays of light move from a patch of sky or whichever source of light that is in the atmosphere at that moment towards the ground, it begins to bend and refract. So the rays travel from air layers of a higher refractive index to lower refractive index. So the rays therefore bend gradually from the incident direction until they enter a certain layer near the ground where the angle of incidence exceeds the critical angle and total internal reflection occurs, meaning that the rays will reflect upwards and reach your eyes and cause you to see the tree and its inverted image. So the patch of sky will be reflected and it will appear as if you are seeing water. It mostly happens in the desert, but most people think it's just hallucination, but it's actually an effect of light.
And that is all for our project.
We are Group 3, and today we'll be discussing what is the definition of recycling, the advantages of recycling, what it can be used for, the uses. My group members are Asmao Abdulsalami, Peace Aitanki, Daniel Daramola, Stephen Adebayo, and me, James Ayeni. Thank you.
So, recycling is the process of turning waste into a reusable material, like what we have here. So, I'm going to pass it on to Danny to explain.
In our mini collection, as you can see, we have example of things that can be recycled. For example, we have glass, or as you can see, glass. We have paper, metal, plastic, a silicone chip, and wood. All these are examples of things that can be recycled.
Okay, now we're talking about why do we need to recycle. So it saves energy, it saves resources, and in the time we are in, all we are talking about right now is to save resources because our world is dying, and recycling is the only way forward to improve our society. and it reduces landfill. We all know when you don't recycle things, they all end up in a dump site, which is actually hazardous for our earth, and our earth is dying. And recycling is basically about going green and saving our world. And it protects our environment, because when we recycle, we save a lot of things from dying. Like now, when we recycle paper, we save a lot of deforestation, because of our trees are very helpful in our environment, and they help to reduce the carbon emissions in our everyday life because of trees taking carbon. And simply doing recycling just basically helps our society. And the uses of recycling, it's the conservation of natural resources. As I've explained earlier, it is to save our resources so that we don't waste what we can actually save. Protection of ecosystem and wildlife. So most times people don't take care of what they dispose of. And like we can see from all those pictures where you see a lot of bottle cans and paper and all those things like inside a river or a stream, which is actually killing the wildlife, like the fishes inside the sea, and it's also destroying some plants and some trees. Recycling reduces demand of raw materials. So when we recycle things like paper, we don't always have to go and cut trees every time we need a text, like every time you need to make a book. You don't always have to go and start cutting a new tree. You can just recycle the paper you had before, which will actually reduce the demand and which will actually make things a little bit cheaper. Then creation of jobs. We all know that recycling is not a one-man's work. A lot of people do recycling, and this also enables people to get jobs because of recycling is on a very huge demand, which can also provide jobs for other people to do. Then it cuts climate change. So to make a simple pen, there's a lot of processes and a lot of things that have to be done before that pen can be made. And a lot of these processes always emit out harmful substances into our environment. And I don't need to tell you that the world is in a very sad place because of the amount of radiation we've been exposed to and the amount of things that are dying in our environment. But if we recycle things that we can recycle, we don't always have to make it from the scratch every single time. And this will actually save our environment and reduce our climate change action. Okay, so with our slide, you can also see some extra things we have put, like newspaper. These are type of paper that you can be recycled. Question. So now we have a smile for her.
So the slide was to show how physics is related to recycling. From the past ones, you saw gravity, you saw electromagnetic waves, you saw conduction, you saw magnetism. Yes. So basically gravity is used to separate materials, glass, paper, silicon, so on and so forth, through larger holes and smaller holes. Magnetism and conduction, since they are metals, magnets attract metals, so it can easily be used to carry it up and put it where they're meant to be. And electromagnetic waves, what the slide says, I'm not sure to explain it. So the rest of the slide answers questions about how recycling helps us, like Peace explained. Basically, why do we need to recycle and uses? And we hope with the project you learn about recycling.
Thank you.
Good afternoon, everyone. We're Group 2, and my group consists of Anita Spiff, Ifeoluwa Akimbile, Mary Mbufe, Adeni Pekun Pomle, and I, Sololo Ashino. Our group presentation is going to be on levels. So before we go on anything, I'd like to define some of the key words that will be in our group. First of all, machines, as you can see on our project. A machine is a device that helps or assists in performing work. It makes the basic work that we do much easier. And levers, a lever is a simple machine that consists of a rigid rod or stiff body pivoted about a stationary point called the focal.
Efficiency of a machine is defined as the ratio of total work output to the total work input. Efficiency is usually expressed in percentage. The formula for efficiency is work done by load over work done by effort times 100. Efficiency is always less than 100% because of the friction of moving parts.
Mechanical advantage. The mechanical advantage depends on both the design
of the machine as well as other factors, such as friction, which needs to be overcome along the load. And we should know that mechanical advantage does not have units.
Velocity ratio. The velocity ratio is defined as the ratio of distance moved by effort to the distance moved by load in the same interval. The VR is dependent on the design of the machine only and is unaffected by other factors such as friction. The formula for velocity ratio is distance moved by effort over distance moved by load. Today we're going to be talking about a specific type of simple machine, that's levers. There are other types like the pulleys and the inclined plane, but we're going to be focusing on levers and the classes of levers.
As for the classes of levers, there are three types. There's the first class lever, the second class lever, and the third class lever. As for the first class lever, the fulcrum is in between the effort and the resistance or load. First class levers are also known as speed changers speed multipliers or direction changers. Examples of first class levers are claw hammers and saws. As for the second class levers, we have the resistance in between the effort and the fulcrum. And examples are the wheelbarrows and bottle openers. Second class levers are also known as force multipliers. The third class levers have the effort in between the fulcrum and the resistance. And examples of third class levers are the human forearm.